Welcome geometry and geometry students. This is Mrs. Fellin. We are actually starting unit 10. So if you grab your student journals, we are on page 280 of your student journal. And that way we can kind of get started on some vocabulary that we're going to be doing throughout the course of this unit. So this first section is kind of heavy in vocab, just fair warning, as you can tell from this list. So I'm going to go through some of the definitions, and then what I thought I would do is kind of go through what it would look like, right? So like a picture. So you probably are going to need some, maybe just if you have some regular paper, computer paper, or just line paper, you're going to probably need some of that for today, just so that you can kind of get an idea of what we're all talking about here with all of these definitions and try to keep them straight. So this whole unit is about circles, which just seems a little odd, right? Because you're thinking, how much is there to know about circles? Actually, there's quite a bit. There's a lot of properties and theorems and so forth. And so some of this gets a little bit confusing along the way. So just try to do what you can to kind of sort out all of the theorems and the rules and different things. Again, I think it's easier to kind of look at a visual, to have a picture. So that way, kind of like, okay, when this happens, this is what I need to do mathematically. All right, so first let's just start off like, what is a circle? So if we're looking at a circle, basically, kind of the formal definition is a set of all points that are equal distant from the center. So, okay. So basically what we're talking about here is we're talking about, we have a circle. So I'm going to go ahead and grab a sheet of paper. Let me grab a marker here. So let's draw a circle. Okay, a big circle. So in a circle, you will have a center. That's going to be our next term. All right, so in our circle, we're going to have our center. And so obviously what we're trying to get at is all of the points that are on the circle that make up this circle. And we're going to actually talk about how to graph a circle here at the end of this unit. But all of the points that make up this circle are all the same distance away from the center. And so that's what makes a circle and not like an ellipse or something else. So that's what's kind of the defining characteristic. So the center is that point that's in the middle, right? So that's equal distance from every other point on the circle. So I guess I'll write that down. The point equal distant from every point on the circle. So what I'm referring to here is like if you picked at any point that is on this circle, it would be the same distance to the center, right? And we know that distance, and one of the next words here is going to be talking about our radius, but that's one of the things that we're going to be referring to. If this were on a coordinate grid, in which we will be talking about graphing circles, so like a little bit more algebraic look at it, then the center would be a coordinate point. A lot of times, instead of calling it X and Y, we call it H and K, and that's just something that we use in algebra. Especially algebra 2. And we use that as we talk about like the vertex or center of a function. So anyway, when we talk about this on a coordinate grid, then we're talking about a coordinate point. Obviously, in not in context of a coordinate grid, then we're just talking about a point that's equal distance. All these points are equal distance from the center. All right, let's go back to radius. So I'm sure you all know what a radius is, but a radius is a line segment. So that's kind of an important piece, I guess, right? So what it's not is it's not a ray, it's not a line, anything like that. It's a line segment with the center as one endpoint. Whoops. Okay, with the center as one endpoint. Okay, and the other endpoint lies on the circle. All right, so if you're looking at our drawing here, and again, it's a segment, right? So we're talking about, one endpoint is on the circle, one endpoint is the center. So we'd consider that to be a radius. Now remember, there are infinite number of radii in a circle, right? Because obviously I can keep drawing a whole bunch of these. I'm just going to label this as radius. But a radius is just a line segment from the center to the edge of the circle. All right, so let's go on to the next one. So this one may be a new one for you. This is called a chord. So a chord is a line segment. All right, so it's a line segment that has both endpoints on the circle. All right, so let's kind of look at our drawing here. So if I was to draw a chord, one of the things I have, so it's a line segment. So imagine you're picking 2 points that are on your circle and you're connecting it. So this is an example of a chord. So it's just a line segment that has both endpoints that are on the circle. So again, it's not a line, it's not a ray, it's a line segment. And there's, again, infinite number of ways we can write a chord. This was just one example. All right, next on our list is diameter. I think you guys, again, are probably familiar with this one. But specifically, it's a chord. So it kind of uses that definition. So it's a line segment that has both endpoints on the circle. But it has to pass through the center. So it's a very specific kind of chord, okay? So if we're looking at this one, and let's say here's my center, I'm gonna try to line this up, and I don't have a ruler with me handy, so bear with me. So it is a line segment that passes through the center. So notice that it's still a chord, right? So it's a chord because both endpoints, it's a line segment, and both endpoints lie on the circle. But we call this one obviously a little bit more specific. We call this a diameter, because it passes through the center. And I'm sure you learned in, I don't know, 6th grade, 7th grade, 5th grade math, somewhere along the line, that a radius that takes 2 radii to equal 1 diameter. So there's a line segment this way and a line segment that way. All right, another word that you may not know is called secant. And so this one is a line, so not a line segment this time, a line that intersects the circle in 2 points. All right, let's go back to our drawing. So this time we're doing it with a line. So for example, I might have this. So again, a line is an infinite number, so it goes on forever. It intersects my circle in 2 points. So those 2 points. So this part of my line would be considered a chord, right? So that between those two endpoints. But because it goes on forever, we consider that a secant. That's what it looks like. All right. Next is called tangent. So we obviously just finished a unit on trig. And so this is a little bit different definition than what we did in our trig unit. So this is a line, but it also can be a ray or a line segment. So this is one where it doesn't really matter, right? So it's a line, a ray, a line segment, can be any of them actually. And the key part here is that it intersects, or in other words, I'm going to put in parentheses touches, because that's kind of what it looks like when you look at the picture of it. It touches or intersects the circle in exactly 1 point. So it's a little bit different than, let's say, any of the other ones we've looked at. So again, it can be a line, can be a line segment, can be a ray. So if I was looking at this one, let's see if I can draw this. So I'm going to put a point here. I'm going to do mine as a line. Again, try to make this so that it touches. So I'm going to make my tangent, this is a tangent line. So see how it touches my circle. It's kind of like skimming off the circle. It's like bouncing off the circle. So it intersects the circle in 1 point. So it's different than a secant. So a secant, for number 1, has to be a line, whereas a tangent can be multiple. And in addition, a tangent only intersects in 1 point, whereas a secant kind of intersects in 2 points. All right, so there's your definition or look of a tangent. The next one is called point of tangency. Well, it's that point that I was just showing you. It's the point on the circle where the line is tangent. So again, I'm not going to give you necessarily a vocab quiz, but what I'd like you to look at here is this is our point of tangency. So noticing kind of, like what they look like, right? So that's kind of what I'm getting at. So you understand what the difference between a secant, a radius, a diameter, a chord, a point of tangency, all those things. Not that you can, regurgitate the definition for me, but that you understand what it looks like. All right, so now we get into the whole kind of conversation about like tangent circles, concentric circles, and common tangents. A lot of different definitions that kind of involve tangent. So tangent circles are two circles that intersect or touch, I'll use that word as well, in one point. So two circles that intersect or touch in one point. All right, I'm going to go ahead and use this paper, but I'm going to use like kind of my white space up here, and I'm going to show you. So I have two circles that intersect or touch in one point. So it might be like I have a small circle, and then I might have a big circle. So if they intersect in one point, it's kind of hard to draw that, but they're going to touch, they share one common point. And so that's what it means to be tangent circles. So this is tangent circles. They intersect in exactly one point. All right, next on our list is called concentric circles. So concentric circles are two circles that have the same center. I guess it could be more than two circles. Two circles, generally that's how you ever see it, that have the same center. All right, so the picture here is going to be kind of a good one as well. So what I'm looking at is, let's say I have a circle, do the best I can here, drawing a circle without a compass, and then I'm going to draw a circle around it. Both of these have a center of this point, whatever this point is here. So they're both, even though they're two different size circles, they both have the center the same. So we call these concentric circles. I think the picture is probably easier on that one. All right, last but not least on this one, we are going to chat about common tangents. So a common tangent is a line, or again, it could be a segment, could be a ray, and so we have a little bit more leeway when it comes to tangents. But so a line, a segment, or a ray that is tangent to two or more circles at the same time. All right, let's take a look at that picture. So on this one, what we're looking at, common tangent. So there's a few different diagrams I could give you, and so I'm not going to give you all possible scenarios, but imagine I had, a circle. This is probably the popular one. So I had a circle, and then let's say I have a bigger circle, okay? Again, here's my center, here's my center. Okay, so when we talk about common tangent, it's a line that's tangent to both circles at the same time. Or it could be, like I said, line, segment, or array. So imagine I have, this would be considered a common tangent. So see how this line touches this circle? It's supposed to, at least touch the circle in one point and touch that circle at one point. But remember, there are many ways we can draw this. So I'm going to move my paper here a little bit. I could also do a line right here, and this would be a common tangent. So see how it hits the circles down there. I could also do a couple in the middle. So this could be a common tangent. So see how it hits the circles into each in one point, and then the other way as well. So in this diagram, I have 4 common tangents, which is kind of interesting. I mean, so like that's kind of a unique kind of scenario. So this is, like I said, probably the more challenging of the examples. So like this example here, there was a common tangent. You could have one common tangent here, right through the middle, through that one point. All right, so that's all the vocab from this section. So to be honest with you, this section is just really heavy in vocab, okay? That's pretty much what this section is all about. We are going to kind of chat a little bit about, let's go ahead and move on to page 281. So let me fast forward here a bit. So there are some good diagrams on your paper about, so, you know, like the chord, the center, all that kind of stuff. I just wanted to point out the common tangent. So like this is 2 points of intersection. This is 1 point of intersection. So those two circles are tangent. Look how they're kind of drawn. I didn't show you an example of that, but they're not concentric because the centers aren't the same, but this is a line of tangent. And so you could touch there and touch there. Concentric circles generally have no points of intersection. So you could have so the one theorem that I think that I'd like you to kind of write down here at the bottom is something called external tangent congruence theorem. So external tangent congruence theorem. So what this is let's say I had a circle, okay, and then I have a point outside my circle, and I have two line segments, I should say, that are tangent to my circle, okay? So from this point, I have two line segments that are tangent to my circle. So what this is saying, let's label these. If we have this scenario, if I have a point, an external point where I have two lines that are tangent to the same circle, or two segments that are tangent to the same circle, then what we know is that AB is equal in distance to CB. So these two pieces have to be equal. And so that's what the external tangent congruence system means, or congruence theorem means. The next one I want you to look at is something called tangent line to circle theorem. Really specific here, right? So again, we're going to draw a circle. What this particular theorem states is that if I have a line that's tangent to my circle, so here's my line, it's tangent to my circle, it will have to be, if it is indeed tangent to my circle, it has to be perpendicular to the radius. So let's just call this A, B, and we'll put another point here, C. So what this means is line segment AB is perpendicular to line CB. So if this line is tangent to my circle, it has to be perpendicular to the radius of that circle. So those are our two kind of main theorems in this section. I just wanted to kind of go over in addition to the vocab. All right, so I would just review the vocab, try the practice of some big ideas, so that way you can kind of get a feel if you are understanding some of this. And then, of course, as always, bring questions to class. All right, bye for now.